Good morning, everyone. My name's Neil Langdown, and I'm the Global Product Director for Trillium's Pump Division. So I'd like to welcome you to an introductory webinar to low-flow, high-head pumping solutions. As I say, this webinar is an introduction, and over the coming weeks, we will be looking to hold a series of webinars to dive into greater detail. So throughout today's presentation, you will have the opportunity to ask questions. And you can do this via the chat function on Teams. We will attempt to answer them in real time, but if not, we will certainly cover these in future webinars. So if we have a look at slide 2, which is the content slide, whilst you digest that, I'm just going to give you a very brief introduction to Trillium. So Trillium Flow Technologies provide pumps, valves, and steam turbines to our customers via our global manufacturing sites. And we support this via a network of our own service centres, but also our authorised third-party service centres. Looking at slide 3, what this indicates is some of the pump brands that we acquired from the Weir Group in 2019, and that includes Gabbioneta, Flowway, Wemco, Begemann, and Roto-Jet, which is the main focus of this presentation today. So this slide here shows a brand timeline, if you will, of Trillium products over the past 100 years. And whilst you digest that, I'm just going to start summarising what you're going to hear today in terms of the content of the webinar. So over the next 30 to 40 minutes, you will hear about Trillium's low flow, high head solution, how it's based on pitot technology, and how we as an organisation have over 40 years experience with this solution under the brand name of Rotojet. We've recently elected to commence the manufacture of the Rotojet at our facility in Italy to serve the European customers, whilst of course continuing to manufacture in the States as we currently do. And this is all about primarily serving the global API market. And you will see that this forms part of our already comprehensive range of API 610 pumps. We look at slide 5. This shows where we're located in terms of manufacturing and service. And as you have a look at that, I want to explain to you a bit of the background to this presentation. So we recognise that the traditional low flow high head solution for downstream oil and gas has historically been an OH6 pump, but we also understand that the voice of customer has been concerned about some of the issues associated with this technology. So, for example, the high rotational speeds, 20,000 RPM, is not uncommon. When failure occurs, it can be catastrophic and very costly. And that's not only in terms of repair costs, but also the associated downtime. Also, one of the issues with OH6 offering is you'll notice there's a very narrow operating band in terms of the envelope, either side of best efficiency point. So you're going to hear how Rotojet addresses not only these issues, but also about some of the additional benefits that it can bring to the end user. So with that in mind, if we move to slide 6, and I will hand over to Ricardo to talk to you about this in greater detail.
So good morning, good afternoon, good evening, everybody. And first of all, let me introduce myself. I am Riccardo Ciceri, and I am the Engineering and Product Director of Trillium Pumps Italy. Trillium Pumps Italy is the Italian plant of Trillium Flow Technologies. Trillium Pumps Italy is the former Weir Gabbioneta, before was Pompe Gabbioneta. In any case, with various names and owners, over 120 years of experience. We are recognized by the market as a highly qualified supplier of reliable and efficient high-quality pumps and after-sales solution as well. For many years, Trillium Pumps Italy has been focused on design and manufacturing of API 6.0 compliant centrifugal pumps. It means sealed overhang between bearing and vertically suspended pumps specifically designed to work in the most severe and demanding environments. Of course, oil and gas is the main market for us, upstream, midstream, and above all, downstream. But our pumps are used also in refinery, chemical, petrochemical, and power markets, wherever are required reliable products extremely customized to be compliant also with customer specification and with a design suitable for the most critical applications. The current product portfolio covers most of the API pump type. For sure, the most important, like for example, OH2 in terms of quantity of pumps, or BB2 and multi-stage in terms of critical applications. We can see that a missing pump are the OH6. The current product portfolio of Trillium Pumps Italy incorporates also the Begemann products, mainly the OH5 pumps compliant with Shell Dep specs. Begemann is another historical brand founded in the Netherlands more than 130 years ago and now owned by Trillium Pumps Italy. To further enlarge our coverage, thanks to the cooperation with Floway, another Trillium Flow Technology brand, in this case based in US, we have also enlarged our proposal, our coverage for the VS1, VS6 vertical turbine pumps. All these different kind of pumps are manufactured in one plant here in Nova Milanese, and these represent an opportunity for customer, for which we are a one-stop shop, a company, Trillium Pumps Italy, fully structured over a strong engineering-to-order process that can follow also big packages with many different kind of pumps, ensuring the same quality level on materials and documentation as well, during and after the project execution. Looking at our coverage of the horizontal pumps, we can see what is missing and how this can be improved. The existing products cover a huge range of operating performances, up to more than 12,000 cubic meters per hour, with maximum head over 3,000 meters. But the existing coverage, the current coverage, has a gap on the low flow, high head applications. This area perfectly fit with the Roto-Jet pumps performance range. For this reason, we are excited to add Roto-Jet to the product manufactured here in Nova Milanese for the European and Middle East market and only for the oil and gas application. We will be able to further increase our capability to offer complete product package and to be, for our customer, more and more one-stop shop for all their API needs. Now, Manju, Paili, my colleagues will give you all details about the Roto-Jet pumps, principles and capabilities. Thank you.
Thank you, Riccardo. Hello, everyone. My name is Manju Paili. I'm a product manager for pumps based out of our facility here in Milan, Italy. And I'll be walking through different options for low flow, high head available in the marketplace, then some of the common features and benefits of the pitot tube technology, a few case studies, and a few takeaways from this presentation. Now let's look through what is a low flow high head coverage. Typically from the market, we are looking at from a few meter cube an hour to around 170 meter cube an hour of flow, and a head of roughly 200 meters to 1600 meters of head. Or if it's a specific gravity of water, then we are looking at 20 bar to 160 bar. And in this area, we have different technologies available which are all established. The common ones, between bearing, axially split from API 610, we call it BB3, or radially split ring section could be BB4, or a radially split pump with a barrel outside, which is the BB5. Then we also use Barsky style impeller on a single stage overhung design. That's common. Sealless canned motor type. That's another option available. And of course, non-centrifugal reciprocating pump is another choice out there. Then high-speed integrally geared vertical inline design is another choice, which is called OH6 and API 610. And last but not the least is the pitot tube. So we'll touch briefly on each of these technologies, and then we will get into the details of the pitot tube. Now, on an axially split pump design, for us to achieve an average flow and head in the low flow high head region, we are looking at roughly 8+ stages. Tight clearance wear rings have to be there. Then, of course, a larger footprint because of the pump size and all the auxiliaries required. Then a higher price to keep a spare rotor assembly. For example, if you take a below 45 meter cube an hour flow rate on a between bearing pump, you're typically going to take a selection which is far below the best efficiency point of such a design, which forces towards a recirculation line and lost efficiency. Now, looking through a barrel style design, which has a radial impeller arrangement. Here also, we are going to have a similar situation where we need 8+ stages, typically larger footprint and higher capital cost because of the barrel. A rotor assembly could be over 100K for such a design. And if we want to repair one of these pumps, most usually this has to be brought back to a repair facility. And as the case of a BB3, we will need a recirculation line to run the pump closer to the best efficiency so that we do not affect the reliability of the machine. Now, looking at another common design available is the OH6 style, which is seen in many locations. This pump typically runs, as my colleague Neil has mentioned, runs sometimes over 12,000 and sometimes up to 24,000 RPM, which makes it very delicate, and if and when there is an issue that may end up in a catastrophic failure, because it has a narrow operating range due to the inducer in the pump design, and it also has a requirement of certain straight line length, and maintaining the gearbox is very crucial. And many times you will need a forced lubrication system and some cases heat exchanger in order to maintain proper operation. Now, let me introduce you into the pitot tube style technology, where we call it Roto-Jet pumps. The pitot tube by itself has been around for over 100 years. We have utilized this technology for more than 40 years from our original plant in Salt Lake City to produce overhung pitot tube style pumps. Is this a centrifugal pump? It is, because it follows the affinity law, which is followed by all the other centrifugal pumps. With the help of a pitot tube pump or a Roto-Jet pump, we are able to achieve the same low flow, high head conditions with the one stage and a much lower speed. As you can see here, it normally runs between 1800 to roughly 6500 RPM. And the overhung design has been running for many decades among many top petrochemical customers like Lyondell, Bessel, BASF, Dow, DuPont, Solvay. There are many customers globally who have been using it. And with the experience and the knowledge and the feedbacks from the customers in the last few years, we have also introduced an even more reliable between bearing design. So in the coming slides, we'll be looking at some of the features, benefits of both the designs and how it differentiates from existing technologies. Now, this is the cross section of the overhung design. Here, the first observation is that it doesn't have an impeller. Instead, we have a pitot tube standing stationary at 12 o'clock position. And here the fluid comes in through the suction line, goes through the mechanical seal here, then goes through a vane channel, which is similar to the vane channel you will see in a centrifugal pump. Half of the head is achieved through here, and the fluid is introduced into the rotor assembly. Here, the green component is the rotor, which means the entire green component is spinning. And as it spins the mass of fluid along with it, and which forces the fluid to pass through the opening in the pickup tube, and it goes through the hollow shaft out the way through the discharge. And to achieve the speed we require, this rotor assembly is connected to an external gearbox, which has different gear ratios to change the pressure, and that is connected to a standard 2-pole or 4-pole motor, which is very similar or exactly the same as what you would use in a traditional centrifugal pump. And here you would also notice it's a standard external gearbox, which is not force lubricated. We have ball bearing for radial and double row for angular contact for thrust. And here it offers a stable operation without any pulsation, very fewer moving parts. And with the pickup tube technology, we are able to change the capacity by changing the pickup tube. And in order to increase the flow, we can either use a single pickup tube, as you will see here, or a double pickup tube, as you may see in this particular cut section. So it is at 12 o'clock and 6 o'clock position. And we can also increase the opening of the pickup tube in order to increase the flow. And one other important feature is the mechanical seal here. The component design is only exposed to the suction pressure, which can go as close as 25-26 bar, and which means you do not need a specialty mechanical seal here. And as you've seen in the previous cross section, the bearing assembly is separated and it doesn't need a force lubrication. And in the coming slides, I'll also explain why this pump is able to run across the entire spectrum in either side of the best efficiency point. Let's look through this video to see how the fluid moves through this pump design. Here in this design, the fluid is entering through the suction line, passes through the mechanical seal and through the vane channels built into the rotor, and then it is introduced into the spinning rotor assembly, where it spins the mass of fluid spins along with the rotor assembly against the stationary pickup tube, in this case standing at 12 o'clock position. As it spins with the tight clearance and unique design of the pitot tube, the fluid is forced through the pitot tube opening, through the shaft, through the hollow, and as it passes through, and when the fluid expands, we achieve 1/2 of the head through that. Here, with one single stage, we achieve the entire low flow high head requirement, and then the fluid leaves through the shaft and out the way. So it's a relatively simple mechanism with the fewer parts, and we achieve the same flow and head requirements in the typical low flow high head applications. As you see in the video, as you increase the speed, we increase the head. And then by increasing the opening of the pickup tube or introducing a double pickup tube, we can increase the capacity. Now let's do some comparison on the specific speed of this type of design. As you see on this graph, we will see different specific speeds, which is a variable of the flow speed and the head. A traditional radial speed pump, you will see around 1500 to 2000, and a partial emission, which has an inducer around 400 to 800. And the pitot tube is even on the left side, in the left side, roughly between 100 to 400. You can see here on a traditional centrifugal pump, it has a slightly higher efficiency. However, depending on which position you take and the amount of recirculation you may have to do, this may be comparable with the pitot tube efficiency or the partial emission. But because the pitot tube is able to offer a higher efficiency and doesn't need a recirculation in many cases, we are able to offer a higher efficiency in many of the low flow high head applications. Now let's look through some other additional features of the overhung design. As you see here in the right side picture, here is the pump with the suction and discharge flanges, then the bearing assembly, which is naturally lubricated, the gearbox, and the driver. This pump is installed on an API 610 base plate. With the traditional API 682 flush plans, we are able to offer all the seal flush plans, including the gas seal. And it's a standard motor, as I have mentioned before. And the pump vibration limits is well within the API 610 all across the spectrum, even when you move to the far left towards the shut-off conditions. And there's no forced lubrication required. One other interesting aspect is the Roto-Jet pump do not require a straight line length. Traditionally, you need at least 3 times the diameter of the suction line for the pump to run smoothly. Here, we can have the suction and discharge line going straight vertically up to your central pipe rack from the base plate, which means you save the space. And the arrangement of the suction and discharge here, it's horizontal. It can be turned vertical if you have a bottom entry and a straight top discharge. These all are benefits you get on this style of design. Now let us look at the next generation of the between bearing design. After learning from the experience and feedbacks from our customers, we introduced further improvements to the proven design. Here, as you can see, we have added the gear package well within the pump casing, which means you do not have a separate gearbox. And the pump casing by itself act also as the oil sump. And here we have a fairly large oil sump, 7 gallons, and this is naturally lubricated, which means there's no external forced lubrication. The same lubrication with the channels built along the pump casing is used to lubricate all the standard bearings. There are 6 of them here, arranged in the pump suction assembly and the discharge assembly. So this design make it very compact. That means the footprint where it matters, it can be accommodated very easily. One other major difference is that the fluid now enters in one area, enters into the pump rotor and exit through the opposite direction, which means there's no thermal heat exchange between the suction and discharge, which means when there are low specific gravity, high temperature applications like a deethanize or depropanize or such application, we do not have to worry about vapor pressure or thermal expansion. Another major advantage here, we have a full API 682 cartridge here on both sides, which means you can work with any standard seal supplier, and for the maintenance and reliability crew out there, they do not have to worry about a component mechanical seal here. It's a regular cartridge, just like any other pumps like we see in a Gabbioneta model. And another aspect here, the pressure containment is well within the rotor assembly, and which means it's impossible for the process fluid to mix with the oil or the other way around, which makes it very safe to run in mission critical applications. From a power perspective, we can go over 300 kilowatts or 400 horsepower. The bearing life, Elton life, it's well above the API 610 requirements. We have even tested on some cases up to 50,000 hours. Temperature, it can run in the low temperature applications like in Canada and some of those areas, or Siberia, and the temperature limit without any external lubrication, we can run it at around 120 degrees, and if we were to add additional cooling, we can go up to 290 degrees Celsius. Now let me show you a video showing the internal mechanisms. Here, as you can see, it is much more compact. The pump is connected directly to the standard motor, and ATEX is available. The fluid enters through the shaft on one side, passes through the vane channels in the rotor assembly, and it is introduced through the holes into the rotor cavity, where it spins along with the rotor, and the fluid is then forced into the pitot tube. And here, unlike the overhung, the fluid is going in the opposite direction, and the shaft, discharge shaft, works also to support the bearing. Everything is all arranged in a very compact manner. So that means there's no thermal exchange, especially for low specific gravity applications. And as I was mentioning before, these gears, along with the other standard bearings, are lubricated with the same oil. And here you will notice that the pump was installed on a standard concrete pad, which the base plate, all it needs is the regular grout arrangements. You do not need any special concrete pad, which means for any upgrades of existing application, your current civil arrangements will be more likely adequate. Another advantage, it's very easy to maintain. The top cover comes off, and the rotor assembly can be moved very easily. And please keep in mind that in order to remove the mechanical seal, you do not need to remove the top cover, which makes it very easy. And from an alignment perspective as well, it makes it easy for the maintenance crew. And with one size, we can change the gear ratios as well as the pitot tube. You can also accommodate the same pump for future conditions, which means in 2 or 3 years time, you have to upgrade the flow or the head. It's very likely you can use the same pump. All you have to look for is the motor is accommodating the future condition. Now, one other key benefit of this design is its flexibility. As you know, working in the rotating equipment industry, many times you have a rated flow where you ask the pump manufacturer to pick the pump. Then you have a normal flow, which a lot of times is outside, or it could be outside the 70 to 120 percentage of a BEP range, which is what is shaded here in the light blue color. And when it happens, this is forcing the traditional centrifugal to pump to run outside the comfort zone where the radial loading is higher. In our case, with a flat radial load all across the spectrum, we are comfortable to run this pump outside the 70 to 120 range, which means by simply adjusting your control valve or your system conditions, you're able to hit multiple points without compromising the reliability requirements of the pump. There's a great flexibility this pump design offers, which also means that when there is an upset condition, for example, somebody accidentally closed or throttled the valve and pump is going way back on the curve, the pump is still going to be fine. Now let's look through a few case studies. This is a petrochemical plant in US, and it's a propane butane mix. As you can see in the right side, this has a dual pressurized seal arrangement, and also the flow rate here is a range, not one value, which means we are comfortable to support the customer on a wider range of flow with one pump, even though this pump is running on a fixed speed. Just by adjusting your discharge conditions or throttling the conditions, you can achieve multiple requirements. It's running at around 1400 meters, low specific gravity, 5,800 RPM, 71 kilowatts. This pump has been running stable for many years now. Another example, this is a case study done by Saudi Aramco, a key customer for us for Roto-Jet, and they presented this case in the Middle Eastern Turbo Machinery Symposium. They had a OH6 or the high-speed integrally vertically inline pump design as a bad actor. They were looking at various pump technologies, both centrifugal and non-centrifugal, and they looked at the between bearing, they looked at the reciprocating, they looked at the Roto-Jet. With the multiple catastrophic failures and the lack of reliability, they looked at all this and decided to go with the Roto-Jet design. As you will see in the picture on the left side, the original pump is on the far right, and the new Roto-Jet pump installed there. The customer has been very happy with the performance and the reliability, and then since then they have bought multiple Roto-Jet pumps for their projects globally. Another example from North America, this is a refinery in the Salt Lake City area where a customer was looking for a reliable solution for a propane butane mix. And after installing this, they also installed the vibration monitoring and the different sensors in order to capture the performance, just to be sure the pump is delivering to their expectation. To their surprise and to our surprise, the pump has seen some various upset conditions along the way, and these are data the customer kindly shared with us. At one point, the pump ran dry, and even with that, the vibration data, as you will see in the bottom row, was relatively stable and well within the API 16 criteria. And as you know, running a pump dry is not recommended. However, even in this case, the seal also didn't fail because we had the lube, the barrier, the buffer fluid which lubricated the seal faces. But this is a good testimony of the reliability of the pump in upset conditions. Let's look to another case. This is a hydrotreater plant, and it is a water with H2S. Around 28 meter cube of flow and close to 900 meters. And this pump is running at 141 kilowatts. So this pump also has been running reliably for quite a while now. It's running at 5,000 RPM, close to 50% efficiency, which is compared relatively high for low flow high head applications. And the red dot points out where it runs in our in the hydraulic coverage. As you can see, there are different pickup tube combinations available, which covers most of the requirements in that in the bracket. Now let's look at another petrochemical applications where the ROFT, which is the between bearing design, has been used. And here It was installed back in April 2019 for olefin or nonene application. This is a 50 US GPM, roughly 3,200 feet of head. So this is another example where customers in the petrochemical industry has chosen Roto-Jet for mission critical low flow high head conditions. And here this is running at 5,000, 5,100 RPM, 125 horsepower, and hitting the flow, the head of 3,500 feet. Now let me touch on some of the material combinations. Here we have multiple combinations available from carbon steel, stainless steel, C6 super duplex, and as you can see, this is comparable to the API 610 Appendix H1. So depending on your fluid conditions, we can offer all these combinations. And we are not showing some of the exotic material combinations we have available. So when you have some unique applications, please reach out to us and we can look at some of the materials I haven't shown here. From a secondary sealing, we have different O-rings, different seal face combinations, which we can work with the seal suppliers. And also for the wet assembly, we can look at some coatings available where needed. Another aspect you will notice, they all are standard angular contact or ball bearings in all the conditions, which means you do not need to have any specialty bearings. Now in summary, we have a pump design which is very relevant for many of the low flow high head applications in the oil and gas industry. We have the overhung design as well as the next generation between bearing design. And here I have mentioned the flow of up to 102 for the between bearing or higher flow for the overhung. The head, we can exceed to over 1600 between either the between bearing or the overhung, and the horsepower over 300 kilowatts. With the flush arrangement, we can hit up to 290 degrees Celsius process fluid. And also for the suction pressure, with some improvements, we can even go about 30 bar depending on the requirements. Again, in comparison to the API 610 requirements, we meet all the intent of an API 610 pump. And from a reliability perspective, we exceed the expectations. And when in comparison with our existing portfolio of Gabbioneta Begemann flowway pumps, we are able to fill the gap and support you with any low flow high head requirements. Another key takeaway for one of the key takeaways from the Roto-Jet design is the flat NPSH curve. Here, this is an indication, this dotted black line is an indication of the NPSH required, and the green line is a indication of the NPSH available at site. And a pump design with an inducer built in, the blue line represents that. Of course, within the inducer operating range, we have enough margin between the NPSH R and the A. However, for any reason you move outside the operating range, you do not have the margin, which results in catastrophic failures. In our case, with the flat NPSH curve, we are much more flexible when you have low specific gravity applications and you move to the right or the left. Another key takeaway, constant or flat radial load. And the red line indicates the radial load on a pump. And as you know, any pump manufacturers will tell you to run the pump closer to the BEP because that's where you have the lowest radial load. And as you move away, the radial load is high, which results in higher temperature, vibration, and lower MTBF. In our case, as you see in the green line here, we can move across the spectrum, which gives you much more flexibility. Another key takeaway, operational flexibility. And here, when you have multiple conditions and you want to run it even without a variable frequency drive, you can hit multiple points without worrying about compromising the reliability of the pump or worrying about some upset conditions at site. So if you have future points which are away from the BEP, don't hesitate to reach out to us. We can accommodate that in this low flow high head design. Last and the most important key takeaway is the cartridge mechanical seal available for the between bearing design. As you see here, it is a full cartridge with the supplied suction spool and the seal plate removed. You can remove the cartridge without even touching any of the bearings, and the same applies on the discharge side as well. This can be done by the operator within an hour. So that's all it takes to remove both seals and replace it at site. It's that simple for maintaining these pumps. In summary, we have a very reliable pump design which is simple, easy to operate, proven, available for any low flow high head applications out there. Let it be new or for a bad actor in your site. In addition to the design, we are fully prepared to support this design with installation support, commissioning, or inspection at site to evaluate your concerns, or to give you advice on maintenance programs or life cycle analysis, or to retrofit or replace one of the pumps at site. Please reach out to us. Now, let me hand over to Mr. John Kavalam to respond to any questions you may have on the pump design or other details. Thank you.
Thank you, Manju. Hi, this is John Kavalam. Thank you very much for your questions. Manju, can you hear me okay?
Yes, I can. Thank you, John.
Okay, great. We've received some very interesting questions, good questions. We're going to answer as many as we can in the allotted time, respecting the time available. The first question, and Manju, Ricardo, Neil, if you want to jump in, please do so. The first question is, what is the suction pressure limitation? So with the ROFT, the maximum suction pressure is really a function of a few things: the rotor material, the operating speed, obviously the fluid specific gravity, and the suction pressure, and the mechanical seal rating. But within that, we can, under normal circumstances, 250 psi, not a problem, is the limit on the suction pressure. We can go above that, but we look at that on a case-by-case basis. Sorry, go ahead.
No, just want to add one comment, John, which I missed during the presentation. The mechanical seal on the between bearing pump, both on the suction side and on the discharge side, is only seeing the suction pressure, which means we only have to deal with the mechanical seal design for that suction conditions, not for the discharge, which is very unique because we managed to have special passage on the discharge side as well to ensure that the mechanical seal on the discharge side is also having the same suction conditions.
Yep, thank you. There's another question on mechanical seals, so I'll touch on that. The question is, it says, although the mechanical seal sees only the suction pressure, doesn't the pressure at the center of the rotor add significant force onto the mechanical seal? It is a correct statement. And on the ROFT, we actually have a center cavity pressure reducing feature, which is patented, which actually brings down the pressure at the center of the rotor down to the suction pressure. So this is a patented feature that we have on the ROFT. We didn't mention we have 4 unique patents on the ROFT, which really made some great technical advances with this product. Several questions about the presentation being shared. Yes, we're going to have this presentation available on YouTube. So Chris is going to get that on YouTube in the next couple of weeks. Let's see. How does the price of an 086 compare with the between bearings ROFT pump? The prices are, again, it depends on the head and flow conditions, but for most part, very comparable. On some of the higher head applications, the ROFT is a much better option just in terms of price. But more than capital costs on the ROFT, we emphasize the saving over the lifetime of the product. Significantly less maintenance, much better capability to operate anywhere on the curve. And you know, like Manju showed you, that even when the pump is operating at adverse condition on a typical centrifugal pump, the ROFT can handle those just because of the unique design of the pitot tube. It doesn't have the radial loads, and it has a balanced axial load. Any deviations on the ROFT list to the API 610? In the standard configuration, there are no deviations to the 610 standard with the ROFT pump. Another interesting question here. Let's see. Efficiency is relatively low for Roto-Jet pumps. How do you counter this argument? And Manju, you can jump into this at any point. So if you look at low specific speed pumps, and Manju showed you this curve with a Barsky type impeller, partial emission impeller versus a pitot tube. And you can see that within that range of 100 to 400 specific speed in US units, the pitot tube is more efficient than the Barsky impeller. So when you're talking about really low specific speed applications, the pitot tube is more efficient than a typical centrifugal pump with an impeller. If you get to higher flows, higher specific speeds, lower heads, yes, you're going to have more options. And most of our centrifugal pumps are designed for the higher specific speeds. Anything to add to that, Manju?
The only comment is there are a lot of times we will see flow requirements in the single digit or in the teens. And especially when you come into that scenarios and with a high over 1,000 meters of head, when we compare it against our own products or some of the others in the marketplace, the efficiency sometimes could be even 10%, 15%. We believe that in such common applications, our efficiency a lot of times over 40%. To up to 60-65% is a competitive advantage, and it gives that efficiency advantage. In fact, that's it.
Okay, good. Another question here: does the Roto-Jet require special lube systems? So as we presented earlier, the ROFT uses and the standard Roto-Jet uses a splash lubrication system. So for standard operations, it goes with the splash lubrication system. In situations where the temperature is below 0 degrees Fahrenheit, or where you need to have an auxiliary heating system for the lube system, then we would need an auxiliary lube pump to circulate the oil. Other than that, we rely totally on the splash lubrication system. And by the way, we have 7 gallons of lubricating oil in that gearbox, which is huge. So in terms of retention time of that oil, it is much better than, for example, the 086 pump. So nothing special, but we can accommodate if you need a oil mist system. Yes, we can accommodate that. A forced lube, external lube pump, we can accommodate that. In very severe Arctic kind of applications, we may have to go with the forced lube with a heater system. Question, maybe Manju, you can take this one. It says, can process leak into the gearbox?
No, it's impossible for the process to leak into the gearbox because they are completely isolated. And in the case of overhang, they are separate. The gearbox is separate. In the case of between bearing, the rotor assembly is isolated. Then we have an air gap in between, and then we have the casting, which do not have any opening. So this is a major differentiator when compared to other technologies, especially the OH6 style, because for us, there's no chance of gear oil getting into the process or the other way around. They are completely separated. Thank you.
We have a question, an application question. Can a Roto-Jet handle a weak carbamate solution, maximum temperature of 297, about 220 GPM, discharge pressure of 500 PSI, suction pressure about 78 PSI. This is the requirement for a Sundyne pump that we currently use. So this is an interesting application. Carbamate is very similar to a soft slurry, though we say that, the Roto-Jet with the pitot tube, we'd like to limit the number of solids. Carbamate, though, is more of a softer slurry. We can handle that. What we have to be careful about on a carbamate application with pitot tube is the flushing operation, very similar to what you have with an 086 or one of the high-speed products. The flushing of the pump after the application is very critical. So you don't have any accumulation of carbamate, and as you know, it can solidify if it is not flushed out.
Just to add one comment, John, we did work on a carbamate application from here last year from the Gabbioneta office, and we had some good discussions. So I request the audience, if they have specific applications, to contact one of the speakers here. The contact details are on the screen. So this application or any applications, please send us the application details, and we'll happy to review this in detail. Thank you.
Yeah, good point, Manju. Any applications, data sheets, if you could send that to us, we'll take a closer look and get back to you. Not just with applications, if you have any additional specific questions that you'd like to ask, get more information, anything on the Roto-Jet, please reach out to any of us. Okay.
Well, again, just to wrap up the discussion, as I mentioned before, the contacts of the speakers are here on the screen. Please feel free to ask us questions or send the details like John said, then we will be happy to run through this on any applications or challenges or bad actors you have at site. And as part of this this training series, we would like to invite you for the next part of this, where we want to look further into the life cycle analysis, like John mentioned earlier. In some cases, our capital cost may be higher. However, when you look at the life cycle cost, because there are fewer components to replace, you get improved reliability, and there aren't any catastrophic failures to worry about, so that the total life cost could be an attractive proposition. We are doing some evaluation then around the reliability, and we're also going to look further into some of the product features in the coming session. So we look forward to speaking to you on the coming session. And in between, please visit our website if you need any other details of other Gabbioneta products or our capabilities here in Milan, or the manufacturing capabilities in North America, where we also do the Roto-Jet. And thank you again. That's it.